In this lesson, we want to find the distance between polar points. All right, so let's say that I asked you to find the distance between this 4, 105 degrees and 3, 225 degrees. How could we do this? We know that if we have the rectangular coordinates, right, and we're working on the rectangular coordinate plane, we can just use our distance formula, right? So if I have 2 points, let's say x sub 1, y sub 1, and let's say another one is x sub 2, y sub 2. Again, it doesn't matter which point you label as which. I can plug into my distance formula. Let's say d, the distance between the 2 points, is the square root of, I'm going to say x sub 2 minus x sub 1 quantity squared, plus we have this y sub 2 minus y sub 1 quantity squared. Okay, so this works for rectangular coordinates, but I have polar coordinates. Okay, so what you could do, and I don't advise you to do this, you could go x is equal to r times cosine of theta, okay? And then y is equal to r times the sine of theta. So you could use that to convert these guys over, okay? Then you could plug in and you'd have your answer. But there's an easier way, okay? We can derive ourselves a little distance formula when we have these polar coordinates. So we could plug into this generically, change up a little bit of notation, and come up with a formula that way. I'll do that at the end of the lesson because I think it's a bit boring. I want to show you this using the law of cosines. I think it's a little bit easier to follow. Okay, so let me erase this real quick and erase this. And let's just start by plotting these two on the polar grid. Okay, so we'll come down here. And first, I'll plot this 4, 105 degrees. So you're going to step out 1, 2, 3, 4 units. Okay, so we're going to swing around to 105 degrees. So this is 4, 105 degrees. Okay, then for the other one, we have the 3, 225 degrees. So I'm going to step out 1, 2, 3 units. And again, I'm just going to swing around here to 225 degrees. And I know this is upside down, but you can still read it. So this is 3, 225 degrees like this, okay? So we've plotted those two guys. So now I want to think about, okay, if I had a little line segment that was drawn connecting those 2 points, I want the length of that line segment, which is the distance between those two, okay? So the first thing we need is to figure out what is the angle between the two, okay? So in other words, what is this angle right here? Okay, if I was to sketch this, what is that? Well, again, if you think about the whole part here, let's say I start from here and I go all the way out here, that's a 225 degree angle, okay? But this angle here is only 105 degrees, okay, right there. So if I consider the fact that to go all the way around is 225 degrees, if I wanted to take this part out, okay, I would be excluding this from here, and I should probably do that in a different color. So if I took this part right here out, I would have the angle that I'm looking for. Okay, so basically you're going to do this with subtraction. You can take the larger angle here, which is 225 degrees, and I could subtract away this smaller angle here, which is 105 degrees, okay? And this would give me 120 degrees. So that's going to be my angle between these two guys. You can see I've already made a little diagram for us with this. So again, this is just the angle between the two. Okay, so we need this. Now, we can set up a little triangle once we know this. We already know that if we had a little line segment drawn from here to here, that the length of it would be 4, right? Because this guy is lying on a circle with a radius of 4. This guy right here is lying on a circle with a radius of 3. Okay, so this would be of length 3. So we have a side of 3, an angle of 120 degrees, and a side of 4. We have the side angle side, which allows us to use the law of cosines to find the missing side. So let's just call this A. Again, you can call it whatever you want. You can do A, B, or C. Just going to call it lowercase a, okay? So let's come down here, and let's remember that let's say you were trying to find this lowercase a being squared, so side A. This is equal to, remember, you're going to think about the B and the C that you know. So we're going to say B squared plus C squared, then minus 2 times, you're going to have the B times the C, okay? And then we're going to multiply this by the cosine, okay, of the angle you know. So it's always going to be opposite of this guy. So in this case, it's going to be the cosine of capital letter A, okay? In this case, it's going to be our 120 degrees, okay? So now all you have to do in this case is just plug in. I'm going to say that A squared, so A squared is equal to, one of the sides is going to be 4, the other's 3. It does not matter how you put it in there, and I'll show you that later on. But basically, let's just go ahead and say we have 4 squared plus 3 squared, okay? And I'll put minus, I'll go 2 times, I'll go ahead and say 4, and then times 3, and then times the cosine of 120 degrees, okay? So once you get it to this point, you're just simplifying. You can replace a with d, okay, because you're trying to find the distance between the two. Doesn't matter, it's just a letter. So I'll say that basically my d squared is equal to 4 squared is 16, then plus 3 squared is 9, then minus, you're going to have 2 times 4, which is 8, times 3, which is 24, and then multiplied by the cosine of 120 degrees. Again, that's going to be in quadrant 2. You have a 60-degree reference angle. So cosine of 60 degrees is a half, so cosine of 120 degrees would be negative 1/2, okay? So to simplify this, 16 plus 9 is 25. Let's just do it right here. We'll say this is 25. And then this would cancel with this. The negatives would also cancel, so this is going to be plus. And basically 24 divided by 2 is 12. So I'll say this is 25 plus 12, okay, which is basically going to give me 37. So we have that the distance squared is 37. And if I want the distance, I'm just going to take the principal square root of each side, and it'll be the square root of 37. Okay, so basically we've found that the distance between those 2 points is the square root of 37. Now, how can we generalize what we just looked at? Let me write this again. We had a squared, but I'm going to call this d squared, right? D for distance, is equal to, we had basically our 2 sides that were known. So we said b squared plus c squared. Let's go ahead and replace this, since when we have polar coordinates, we're going to have something like r sub 1, let's say theta sub 1, okay? And the r sub 1 is the length of a line segment or a side of the triangle. And then we also have the r sub 2 comma theta sub 2, okay? So what we're going to do is we're going to plug in, instead of the b and the c, I'll go ahead and just say this is r sub 1. I'm going to put this in parentheses because it gets kind of messy. So r sub 1, that's being squared. And this one will be r sub 2, this is being squared. It does not matter which point gets labeled as which, and I'll explain why that works out in a moment, okay? So then you're going to put the minus here, and then 2 times, again, it's these guys. Remember, with the formula, it was 2 times. In this case, it would be b times c. It's basically those 2 known sides. So I would say times r sub 1, and then times r sub 2, and then times cosine of the angle that you know. Now, in this particular case, remember how we found this? We subtracted, okay? So I'm going to do is I'm going to say that I have theta sub 2 minus theta sub 1. The reason it doesn't matter here is that, let's say you end up with something that's negative. Remember, with cosine, you have this negative angle identity. So the cosine of negative theta, okay, if it ends up being negative, is the same as the cosine of theta, okay? So it doesn't matter if you produce a negative angle there, it's the same as if it would have been positive, okay? So you will get the same result either way. None of this stuff matters in terms of the order, right? You're just doing some simple operations here. So the order that you choose the points does not matter. Very important. Okay, so this would be our formula. Of course, you could take the square root. So you could say d is equal to the square root of, and I could basically just copy all this. And let me go ahead and copy that real fast. And let me paste this in, and I'll just stick that underneath there so we don't have to write it. And let me just make that a little bit longer, and I'll just slide this down a little bit so it fits on the screen. Okay, so definitely something you want to copy down for your notes. And let's go ahead and just look at some examples. So we have 2 comma 120 degrees, and then 4 comma 210 degrees. Again, you can label these however you want. It comes out the same way. So let's say this is r sub 1, and this is theta sub 1. Let's say this is r sub 2, and this is theta sub 2. So the distance between the two, let me go ahead and write it out a few times so you get used to it. So r sub 1 being squared, plus you have your r sub 2 being squared, and then minus 2 times your r sub 1 times your r sub 2, and then multiplied by the cosine of the angle between them. So we're going to say theta sub 2 minus theta sub 1, okay? So let's just go ahead and plug in. We know that everywhere we see r sub 1, we're going to plug in a 2. So let's put 2 squared here, and let's put 2 here, okay? And then everywhere we see r sub 2, we're going to put 4. So let's go ahead and put a 4 there. We don't really need parentheses there. And let's put a 4 there. And then for theta sub 2 minus theta sub 1, you're going to have 210 degrees minus 120 degrees, which would be 90 degrees. So let's just go ahead and put cosine of 90 degrees. Now, most of you know that cosine of 90 degrees is 0, so you could basically get rid of this, right? So you can just erase this. You don't even need it because you'd be subtracting away 0, which doesn't change anything. So here we're just going to have the square root of 2 squared plus 4 squared. So 2 squared is obviously 4, and 4 squared is obviously 16, okay? And then if we add those together, we would get 20, okay? So the square root of 20, remember you can simplify this. We could say d is equal to, this would factor into 4 times 5, and 4 is a perfect square. right? So basically I can say this is 2 times the square root of 5. Okay, so that's going to be my answer for the distance between these 2 points. Again, if you change up the ordering, pause the video, you can see this on your own. The only difference is you're going to end up with the cosine of negative 90 degrees. And you could say that the cosine of negative 90 degrees is equal to the cosine of 90 degrees. In each case, and let me put my degree symbol in there so that's better. In each case, you're going to get 0. Okay, so remember this identity here. Let's take a look at another example. Here we'll work with some radians. So let's just go ahead and label this as r sub 1 comma theta sub 1. Let's label this as r sub 2 comma theta sub 2. And again, I'm just going to plug into the formula. So the distance is equal to the square root of, let's just go ahead and say r sub 1 is 3. So we'll say 3 squared plus r sub 2 is 2. So 2 squared, then minus 2 times, you can have r sub 1, which is 3, times r sub 2, which is 2, and then times the cosine of, this one's a little bit tricky because you do have to work with fractions here. So let me do this off to the side. I'm going to have pi over 2, and I'm subtracting away 7 pi over 6. Okay, I need a common denominator, so I'm going to multiply this by 3 over 3. So this would be 3 pi over 6. 3 pi minus 7 pi is negative 4 pi. So this would be negative 4 pi, and then over that common denominator of 6. And of course, you can reduce this fraction. This would end up being negative 2 pi over 3. Okay, so negative 2 pi over 3. Let's write that in here. Negative 2 pi over 3. Okay. Now, if you want to, remember, because of the negative angle identity for cosine, this is the same as if I had cosine of 2 pi over 3. So you can just get rid of the negative there. That way it makes it a little bit easier if you're working off the unit circle. And from here, I can just go through and evaluate things. 3 squared is going to be 9, and 2 squared is going to be 4. And basically you have 2 times 3, which is 6, times 2, which is 12. So this is a 12 here. 9 plus 4 is 13. Let's just go ahead and do that real quick. And essentially the cosine of 2 pi over 3, remember 2 pi over 3 is 120 degrees. And we already know the cosine of 120 degrees is negative a half. So this is times negative 1/2. I like to wrap this in parentheses because basically you want to do this operation first. I know that's pretty obvious for most people, but I don't want you to get confused as to what's going on. So this is going to cancel with this and give me a 6 here. So basically you would have a negative 6, right? So what you end up with here is minus a negative 6, which is like adding 6. So 13 plus 6 would be 19. So basically here the distance between these 2 points would be the square root of 19. All right, what I want to do now is look at 2 different examples where you have these negative angles and also the negative r values. This is a bit tricky for students to understand. You can basically just take what you have, okay, as it's given, and plug it into the formula, and it's still going to work, okay? So I'm going to use this directly as it's given, then I'm going to change it over, and I'll show you why it doesn't make a difference. So first and foremost, we have 4 comma negative 30 degrees. Let's say this is our first point. Again, it doesn't matter how you label this. I'll go ahead and say this is r sub 1 comma theta sub 1. And then let's say this 4 comma 210 degrees. Let's say that's the second point. So r sub 2 comma theta sub 2. Okay, so from here we just plug into the distance formula. So d, the distance between the 2 points, is the square root of. You're going to take this guy and square it, so 4 squared. Plus, you're going to take this guy and square it, so 4 squared. And then minus, you have your 2 times this guy times this guy. So 4 times 4, okay? And then times the cosine of the angle between them, okay? So what I'm going to go ahead and do is just say it's 210 degrees minus a negative 30 degrees, okay? Remember, minus a negative is plus a positive. So 210 degrees minus a negative 30 degrees, okay? And let me go ahead and close that down. And from here, we're just going to simplify, okay? So I'm going to say the distance between the 2 is equal to the square root of. This would be 16, and this would be 16. 16 plus 16 is 32. So let's write that. And then minus, you have 2 times 4, which is going to be 8, and then times 4 again, which is going to be 32. Okay, so you have 32 there. And then times, you're going to have the cosine of 210 degrees minus a negative 30 degrees is 240 degrees. So let me put 240 degrees there, okay? So let me just scroll down and get a little bit of room here so we can fit everything on the screen. So I'll say the distance is equal to the square root of. The cosine of 240 degrees, again, this is going to be in quadrant 3 now. And you're going to have a 60-degree reference angle. So this is going to be negative 1/2. Okay, so you would have 32 minus, you'll have 32 times negative 1/2. Again, if you want to make this clear, it's not necessary. You can wrap this in parentheses. It's kind of up to you. So I'm going to cancel this with this and put a 16 here. So basically you would have 32 minus a negative 16. That's why I like the parentheses there, so it makes that clear. So basically 32 minus a negative 16 is 32 plus 16, which is 48. Okay, so this is the square root. Let me make this a little bit smaller. This is the square root of 48. Of course, 48 is going to be 16 times 3, and 16 is a perfect square, right? It's 4 times 4. So you can go ahead and write this as 4 times the square root of 3, okay? So I'm going to say the distance is 4 times the square root of 3. Now, I want you to pause for a minute because some of you who try to plot this, if you go back up and you think about these points here, 4 comma negative 30 degrees and 4 comma 210 degrees, if you think about the angle between them, it's not 240 degrees. It's going to be 120 degrees. So why in the world did we get the right answer? And I'll show you in a moment that if you do it the other way, you'll still get the same thing. If we go to a little diagram here, you'll see that I've kind of drawn everything out. If you start at this point here, let me label this so everything's crystal clear. This point right here could be thought of as either 4 comma 330 degrees, or if you're rotating this way, clockwise, you could say that it's 4 comma negative 30 degrees, okay? And then this point over here, you could think about it again as 4 comma 210 degrees, okay? 4 comma 210 degrees, like this. Okay. So if we think about the angle between these, you can just look here. I've already kind of done this for you. But essentially, if you start at this 330 degrees and you subtract away the 210 degrees, you can see this angle between them would be 120 degrees, okay? The angle on the outside is going to be 360 degrees, one full rotation, minus this 120 degrees, which is 240 degrees. Okay, so that's if I started here and I rotate along the outside there. Okay, so that's 240 degrees. Okay, so we see that the angle should have been 120 degrees. So what in the world is going on? Well, it turns out that we have a little identity, and it states that the cosine of, let's say, 360 degrees minus some angle theta, okay, whatever it is going to be equal to the cosine of that angle theta. So this is exactly what we just came across. We see that the cosine of, let's say, theta is 120 degrees. So 360 degrees minus 120 degrees, okay, would be equal to the cosine of 120 degrees. This right here would end up being 240 degrees. So the cosine of 240 degrees is equal to the cosine of 120 degrees, okay? So it does not matter if I punch this in as 120 degrees for the cosine or 240 degrees, that value is the same. Okay, so when you go through and do your calculation, you're going to get the same answer, whether you work with it as is or you do a little conversion. Okay, now this little identity here can be quickly proven using the difference identity for cosine. Okay, so if you want to go through that, you could basically say that this guy right here, let me erase this real quick, and we'll go ahead and say that this is what? This is going to be the cosine of the first guy, so 360 degrees, okay, times the cosine of the second guy, so that's theta. Then remember, with the cosine difference identity, the sign is going to be opposite, right? So I'm going to make this a plus. And then I'm going to go ahead and say, now that I have the sine of this first guy, the 360 degrees, and then times the sine of theta. Now, I know the sine of 360 degrees is the same as the sine of 0 degrees, and the sine of 0 degrees is going to be 0, right? So you can basically get rid of this. This is going to be 0. And the cosine of 360 degrees is the same thing as the cosine of 0 degrees, and that's going to be 1. So you can get rid of this. This is a 1. So basically what you're left with here is 1 times the cosine of theta, which is just the cosine of theta. Okay, so that proves that little identity there. We can get rid of this and go back to this form. And let's go back now, and let's see what would happen. Let me go ahead and erase this. We'll keep this kind of here for now. Let's see what would happen if we converted this over. Instead of having 4 comma negative 30 degrees, let's add 360 degrees and say that our other point is now going to be, and I'll just write this over here, we'll say it's 4 comma 330 degrees. Okay, so I'm just going to put this over here and just line this out for a moment. And I'll say this is my r sub 1 comma theta sub 1. And maybe we can just erase this for now, just so it's clear what we're doing. And so in this particular case, what will we do now? Well, we're going to say that we still have the same 4 squared plus 4 squared. and then minus 2 times, you have your 4 times 4, okay, so that part's all the same, and then times the cosine of, this part would be different, so basically you have your 210 degrees minus your 330 degrees, which is negative 120 degrees. Again, remember, because of your negative angle identity with cosine, you could just make this positive 120 degrees, okay, it's going to be the same thing, and essentially we already know that the cosine of 120 degrees and the cosine of 240 degrees will be the same, right? We just saw that identity. So we know we would get the same answer. So we can go through here and just say, okay, well, this would be 16 plus 16, again, that's 32. And then minus, you'd have 2 times basically 16, which is 32. And then times the cosine of 120 degrees, we know, is again negative 1/2. Okay, so you can wrap this in parentheses. Same thing we did before. This would cancel with this and give me 16. So this is negative 16. Again, you get 32 minus a negative 16, which is going to be 48. Okay, so we end up simplifying this. And we get the distance between the 2 points is 4 times the square root of 3. Okay, so it doesn't matter if you end up with a negative angle, you can work with your formula either way. Okay, let's look at an example with a negative r value. So again, you have the choice of working with it as is. Some people tell you to convert it. If you plug it into the formula, you will get the right answer. Okay, so if you have something like negative 3 comma negative 165 degrees, and then 4 comma 45 degrees, if you wanted to, remember the little formula. If you have r and negative r, what you have to do is add 180 degrees to that, okay? So that's how I could change this over. I could say that this same point could be located by saying I have 3, comma, add 180 degrees to this, this would be 15 degrees, okay? So you can use either one. Let's go ahead and use the first one, and I'll show you it works the same either way. So the distance is equal to the square root of, let's call this point 1, so r sub 1, comma, theta sub 1. Let's call this point 2, so r sub 2, comma, theta sub 2. And again, all I'm going to do is just plug in. So I'd have negative 3, so negative 3, be careful there, being squared, plus you'd have 4 being squared, and then minus 2 times negative 3, okay, times 4, and then times the cosine of, if you subtract 45 minus a negative 165, that's like 45 plus 165, okay? We put my degree symbols in there. So that's going to give me 210 degrees, okay? So this is 210 degrees. Let me extend this a little bit over. All right, so let me put here that the distance is equal to the square root of. If I square negative 3, I get 9. If I square 4, I get 16. If I add 9 and 16 together, I'm going to get 25. Okay, so that's pretty simple. Here, what I'm going to do is I'm going to say negative 2 times negative 3 is positive 6, and then positive 6 times 4 would be positive 24. So let me put plus 24 times the cosine of 210 degrees. Now, 210 degrees, that's going to be in quadrant 3, okay, so cosine's negative, and it's based on a 30-degree reference angle, okay? So the cosine of 30 degrees is square root of 3 over 2, and because we're in quadrant 3, this would be negative. So I'm going to say this is the negative of the square root of 3 over 2, okay? So if you multiply these together, what's going to happen is this would cancel with this and give me a 12, okay? And it's going to be negative. So I might as well just write minus, and I'll say 12 times the square root of 3, okay? Times the square root of 3. Now, you can approximate this if you want. If you want an exact answer, this is going to be it. All right, so let's work with this point. I'll show you it still works. So we'll go ahead and say, change that r value to positive. At 180 degrees to negative 165 degrees, that's 15 degrees. Let's line this all out. Let's get rid of that. And I'll label this as r sub 1, comma, theta sub 1, okay? So if you plug in, here the sign's going to change, and here the sign's going to change, okay? And this is going to change. Everything else would be the same, right? So basically what you'd have here is inside, now you do 45 degrees minus 15 degrees, okay? And that's going to give me 30 degrees. So I want you to notice that a moment ago, we had the cosine of 210 degrees, okay? And essentially, this had a 30-degree reference angle, but this guy is positive and the other guy's negative. But notice that you have a sign change here. Okay, before you had negative 2 times negative 3, now it's negative 2 times positive 3, okay? So I'm going to show you a little identity in a moment that proves that this is basically going to work, right? So if you add 180 degrees to your angle, okay, it's going to change the cosine of that from negative to positive, okay? Or from positive to negative. So essentially what I have here is 9 plus 16, which is 25 again. So that part is the same, okay? And then here we have 2 times 3, which is 6, times 4, which is 24. So this is minus 24 now. You can put plus negative 24 if you want. Okay, and we're going to multiply this by the cosine of 30 degrees. We know that this is going to be the square root of 3 over 2. Okay, and so from here, this cancels with this. Again, it's negative times positive, so it's still negative. So it's going to be negative 12. So negative 12, let me erase that and put negative 12 times the square root of 3. Okay, so you see you get the same answer either way. Okay, so let's talk about why this works. Let's get rid of all of this. Again, when I think about something like the cosine of some angle theta plus 180 degrees, this is going to be the negative of the cosine of theta. So you saw with our example, we basically had a theta that was 30 degrees, right? If I added 180 degrees to that, I got 210 degrees, and that's going to be the negative of the cosine of 30 degrees, okay? Again, you can prove this with the cosine sum identity. So if you wanted to do this, you could say that you had what? The cosine of the first guy, theta, and then basically times the cosine of 180 degrees. Now, you know this is -1, so you can just replace that. Just put a negative out in front. And then you're going to go minus, right, because it's always the opposite sign. So it's going to be sine of the first guy, so theta, times the sine of 180 degrees. Now, the sine of 180 degrees is 0, so you can get rid of this. And you're just left with the negative of the cosine of theta. So it doesn't matter if you get a negative r value. If you change that over to a positive, then your angle is going to increase by 180 degrees, okay? So you're going to change the signs on the middle part, but then you're going to compensate for that because your cosine value is going to change signs as well, so you're going to come back to the same answer.